Hello and welcome back to another exciting episode of math. Today we're going to be talking about non-proportional relationships. Let's go ahead and start with the Math Matters guy.
Buying a new car may sound like fun, but you also have to make a lot of tough decisions. You not only need to know the car's sticker price, you also need to know how much it's going to cost to fill the gas tank, and how often you're going to have to fill it. You can figure that out with equations that show the linear relationship between the number of gallons in the tank and the number of miles you can drive on each gallon. The total cost for one tank can be divided by the distance it'll carry you. Then you know the total cost per mile. Calculating your cost changes a bit if you're driving an electric car. The sticker price may be a bit higher, but the cost per mile can be quite a bit lower. These amazing vehicles don't run on gas. They run on batteries, but calculating the per mile cost is still the same process. The battery in this car will let it drive about 40 miles between charges, and each charge costs about $1.50. That means it's only about 4 cents a mile to drive. So this electric car is going to cost more up front, but over its lifetime, it'll actually be cheaper. And that's another reason math matters.
Okay, go ahead and hit pause and add this to your table of contents. Start a new entry. So in this lesson, we're going to use tables, graphs, and equations to represent linear non-proportional relationships. So far, we've only talked about proportional relationships, but non-proportional relationships are out there too. So let's look at these two situations here. They both have the same rate of change, but one's proportional and one isn't. So on the left here, we have Bob. He puts 20 bucks in his savings account every month. On the right, we have Bill. He also puts $20 in his savings every month, but he started his account with 100 bucks. He got birthday money or something, and he started with 100. They both have that constant rate of change of increasing $20, but why is one proportional and one not? Well, let's look at K. That's how we figured out in the past if they're proportional or not. By now, hopefully you know that we want to go dollars per month, not month per dollars. So if I go 20 over 1, I get 20. If I go 40 over 2, I get 20. And if I do 60 over 3, I also shockingly get 20. All right, let's try Bill over here. Here's his X and Y. If I go Y over X, right here, I get 120. The next entry for month 2, if I go Y over X, I get 70. And for month 3, I'll do it up here. If I go Y over X like that, I get like 53 and a third dollars, something like that. Not the same, not proportional, but still increasing by 20 every time. All right, let's do an equation for each one. Well, we know that this one, we found the K of 20, so we know that Y equals 20x. This one we also know has a slope or an increase of 20, but it started with 100 in it. So we're going to write Y equals 20x, because he's still putting $20 a month in it, but he started with that 100. So we can even see from their equations that they're different. Their graphs are different too. So here's Bob's graph. Here's Bill's graph. Are their slopes the same? I mean, they should be. They're going up $20 each. Let's lay them on top of each other and see. Yep, same slope. This one we can tell is proportional because it's coming out of the origin as a straight line. This one is not coming out of the origin. It's starting at 100 bucks. All right, so proportional, non-proportional relationships can also be expressed as we saw with tables, graphs, and equations. So let's look at how we do that. Go ahead and pause and copy down these steps. We're going to pick some x's that make sense, and then we're going to plug and chug our formulas. Let me show you what I mean. If we're going bowling and it costs $2 to rent these super attractive shoes over here and $3 per game, we can use the equation y equals 3x, $3 per game, plus $2 to rent the shoes to show the charge for a person renting a pair of shoes and playing x games of bowling. All right, so we're going to pick some x values that make sense. In this situation, we're not going to play negative games of bowling, but we could potentially, I guess, play 0. We could play 1, 2, or 3. Any more than that, your arm would be getting pretty tired. So instead of x, we're just going to do what you did in 6th grade, and we're going to substitute. So instead of x, I'm going to put 0. And I know that's 0 plus 2, which is going to give me 2. And that gives me an xy pair of 0, 2. If I plug in 1, I get 3 times 1 plus 2, which ends up giving me 3 plus 2, or 5. If I plug in 2, that gives me 6 plus 2, which is 8. And if I play 3 games, I'm going to pop a 3 in place of that x. And that's going to give me 9 plus 2, which is 11. And I can use these to give me some xy coordinates, which I could turn around and use to make a graph. So 0 games would cost me $2 to sit on the bowling alley. 1 game would cost me $5. 2 games would cost me $8, and 3 games would cost me $11. All right, let's try one together. Take out that note-taking form I gave you. Right on top of it, use the equation to fill in the table and write in this equation, please. All right, go ahead and put it in this box as well. All right, we're going to use some x's that make sense. If we don't have a situation like bowling, we want to have at least one negative, at least one 0, and at least one positive. So let's just do -1, 0, 1, and 2, because ultimately we're going to graph these, so we want lots of points to play around with. Okay, now we're just going to pop in these x values in place of x in the equation. We're going to show our work. That ends up being -2 plus 5. Different signs subtract, positive wins. So now we're going to pop in 0. And we're going to get 0 plus 5, which is 5. We're going to pop in 1. And get 2 plus 5, which is 7. And then we're going to pop in 2. And we're going to get 4 plus 5, which is 9. Put these pairs together. Make some x's and some y coordinates. And then there you go. Go ahead and hit pause, grab a piece of scratch paper, make yourself a little chart like this. Well, actually, I have a paper for you that has this little chart on it, so go ahead and use that chart and try out this problem. All right, so now let's take those tables and turn them into graphs. Go ahead and hit pause and write this down. We're basically going to do the same thing. We're going to make an XY table, and then we're just going to turn around and plot those points. We're going to choose some x's that make sense with the situation. So this is a funkier equation. This is 2/5 x plus 10. So I want a number that whatever x is going to be, I want to be able to times it by 2 and divide it by 5 and have it to be a nice, pretty number. Right. We also want to read the situation here. So we're talking about growth of a tree. So if it's 10 inches right now, and over the next 50 years, it's expected to increase by an average growth rate of 5 inches per year. And this is going to give us the predicted diameter of the tree after X amount of years. So we want to pick, we're not going to use any negative stuff because the tree's not going to grow for negative years. So I'm going to go ahead and choose some things like 10 years, 20 years, 30 years, and it talked about 50 years, so we'll use that one as well. All right, so I'm going to go 2 times 10 over 5. That's how I'm going to get my 2/5 x. Okay, so I'm going to go 2 times 10, which is 20, and 20 over 5 plus 10. Sorry, my writing's small. So that'd be 4 plus 10, which is 14. And I'm going to keep doing that. 2 times 20 over 5, so that's 40, divided by 5, which is 8, and 8 plus 10 is 18, and so on and so on. I'm going to go ahead and pause and fill this in. All right, well, you're welcome, because that was not exciting at all. So I have finished doing my math here. I've gotten my points, and then I can take those points and make a graph and see how my tree is predicted to grow right there. Okay, make sure to come in tomorrow with the example I asked you to do for your notes and the example that I asked you to do on the practice page. And also let me know any questions that you have. All right, get a good night's sleep, and I will see you in class tomorrow. Bye.